Okay. And then tomorrow after the quiz, we'll actually introduce tangent and possibly cotangent as well, I forget. And then next week we'll look at secant and cosecant and graphing those. But the good news is if you're comfortable with graphing sine and cosine, then you should be okay with graphing secant and cosecant. It's just kind of like a, one additional step from sine and cosine, essentially, when we do secant and cosecant. Okay? Anywho, so let's look at horizontal shifts first. Okay? And the way that's going to show up, well, again, if we have, the a in front of our function, that's going to result in an amplitude change, right? It's going to be a vertical stretch. We have that a in front there, right? We saw that one yesterday. And then the bx, okay, that bx is going to be a horizontal stretch or shrink. Okay, that b there, right, determines a horizontal stretch or shrink. And then minus c is what we're introducing today, and that then is going to be our indicator of a horizontal shift. Shifting things left to right, not stretching or shrinking the period at all, just shifting things left to right. And then likewise, of course, for cosine, same idea, a cosine bx minus c, like that. Okay, where again, the minus c is going to adjust horizontal shift, or going to affect the horizontal shift there. Okay. What we did yesterday, if you remember, to kind of like account for that horizontal stretch and shrink, we took, what was inside the parentheses there, in case yesterday it was just the bx. We took what was inside the parentheses, put it between 0 and 2 pi, our kind of like, initial, normal, typical period for sine and cosine, and then we solve for x to do the correct adjustments for the new period. We're going to do the same thing here, except now we're going to take the entire quantity bx minus c and put that between 0 and 2 pi. And then this will allow us to both account for the horizontal shift and the stretch or shrink that might be there, okay? We just then solve for x. Okay, so let's take a look at that as an example here. We'll do y equals the cosine of x minus pi over 3. Okay, so knowing what we know about transformations, we know it's going to be a shift, right? This is going to be a shift in which direction? To the right, how much? Pi over 3, right? So instead of our period starting at 0, our initial period kind of starting at 0 and going to 2 pi, instead we're going to shift everything right pi over 3. So instead of starting at 0, we'll now start at pi over 3. And instead of starting at 2 pi, well, we'll start at 2 pi plus pi over 3, which will be 7 pi over 3. Okay? And again, we'll see that here real quick. I'll do the little calculations. So we'll put that, shift there between 0 and 2 pi. And then we'll just add pi over 3 to both sides. And so we then start at pi over 3. And then 2 pi plus pi over 3 is going to be, well, that's where you get the 7 pi over 3. Okay. So all we did there, right, was just add pi over 3 to all three sides there to then get this new interval, our new kind of initial period. Okay? What is the amplitude of our graph going to be? What's the amplitude going to be? 1, right? What's the coefficient of cosine? Just a 1, right? So our amplitude here is 1. What's the period length? What's the length of our period? Or just what's the period length here? It's 2 pi, right? Did we stretch or shrink at all? Right? There's no number in front here. It's a 1. So we didn't stretch or shrink our period. So the fact that we went from 0 to 2 pi, that period length was 2 pi. We still have a period length of 2 pi here, right? You can check it by just taking your right endpoint, subtracting your left endpoint. 7 pi over 3, take away pi over 3. That distance is 6 pi over 3 or 2 pi. So the actual period length did not change. It's just where the period starts and stops, okay? Or where our normal period starts and stops kind of thing. That's changed. So the period here, or the period length, however you want to call it, we'll say that's 2 pi. Still. Okay, we didn't stretch or shrink at all. So now we'll graph. Sketch the graph. Okay. our range, the range for our function will still be what to what? Negative 1 to 1, right? Negative 1 to 1. Because our amplitude's 1, so it'll still be negative 1 to 1 there. Okay, and we'll do 2 full periods here. So we're not going to start at 0. We're going to start at pi over 3. So I'm just going to kind of like go out a certain distance here and say, aha, there's pi over 3. Okay, and then we'll go out to 7 pi over 3. Say like, I don't know, we'll say like right here. Okay, so there's 1 full period. And then, of course, we want to find those kind of like intermediate points, those middle kind of behavior points, if you want to say it that way. So we want to find the midpoint and then like the quarter points here. Because again, those midpoints and quarter points, that'll help us find, you know, our peaks and our valleys, and then, you know, kind of like our middle part of our graph too. Okay, so we have to find the midpoint between pi over 3 and 7 pi over 3. Well, how do you find the midpoint between 2 numbers? Just generally speaking, what do we do? Add them together, divide by 2. So pi over 3 plus 7 pi over 3 is 8 pi over 3. Divide that by 2, 4 pi over 3. Okay, 4 pi over 3. Okay, then we want to find the quarter points. So pi over 3 plus 4 pi over 3, that's 5 pi over 3, right? So add these two together, pi over 3 plus 4 pi over 3, 5 pi over 3. Divide by 2, or you can think of it as multiplying by 1/2. 5 pi over 3 times 1/2 will be 5 pi over 6. Okay, and then likewise here, 4 pi over 3 plus 7 pi over 3 will be 11 pi over 3, divided by 2, 11 pi over 6. Okay. So we're going to do 2 full periods. We'll do the first period here, and then I'll do the next one here too. Okay. So then we're going to start at pi over 3. Don't start at 0. Okay, don't start at 0 because our initial period here, our new kind of period, our transformed period is starting at pi over 3. So start at pi over 3, plug pi over 3 in. Pi over 3 minus pi over 3, 0. Cosine of 0 is 1. Okay, plug in 5 pi over 6. 5 pi over 6 minus a pi over 3, well, if you do the math there, 5 pi over 6 minus pi over 3. Pi over 3 is the same thing as 2 pi over 6. So 5 pi over 3 minus 2 pi over 6 is 3 pi over 3 pi over 6, which is then pi over 2. Okay, so sorry again. 5 pi over 6 minus pi over 3. If you get a common denominator there and subtract, you end up getting pi over 2. So it's cosine pi over 2, which is 0. Okay, and then 4 pi over 3, well, you can kind of get the pattern, right? We were off the axis, we're on the axis, now we're back to off the axis, back to on, and then back to above there. Okay, and just kind of connect the dots. Use your pattern there to help you. Okay, so there's one full wave. Okay, so questions just on that first initial period there. Any questions on any of that? Okay, so let's say we want to do another full period here. Well, again, we know the length is 2 pi. So if I want to figure out where my next period is going to end, we'll take 7 pi over 3 and we'll add 2 pi to it. So 2 pi is the same thing as 6 pi over 3 plus 7 pi over 3, so it would be 13 pi over 3. Okay, like that. And again, we'll find the halfway points. So 7 pi over 3 plus 13 pi over 3 is 20 pi over 3, divided by 2 is 10 pi over 3. 7 pi over 3 plus 10 pi over 3 is 17 pi over 3, divided by 2, 17 pi over 6. And then 10 plus 13 is 23, divided by 2 will be, well, then 23 pi over 6. Okay, doing a lot of fraction arithmetic here, everyone's favorite. But again, we can just follow the pattern too. So we were off 1, so we'll go back to the axis, back to -1, back to 0, and then back to 1. And voila. And of course, you know, it kind of keeps going too, but there's our 2 full periods. Okay? questions on any of that? Yes.
On the test, would you have to label each and every interval, or could you just label enough to establish a scale?
Good question. So in a case like, you can label enough to establish a scale, but you have to be careful here because the scale that I'm counting by here is technically not equal everywhere, I think, right? Because I go from pi over 3 then to 5 pi over 6, so I'm adding, let's see, that's 2 pi over 6, so 3 pi, so I'm adding pi over 2. So it doesn't like, I kind of am doing a little bit of like jumping here, like that almost, where we don't quite establish an equal interval with that first pi over 3, but then every other point after that will be equal. So you want to be careful with that, I guess. I prefer you to write them out. I think yes, I want you to be able to write them out. Yes. Okay, which I know maybe is a little overkill, but I think I want you to write them out. Yeah. I want you to write them out. Yeah. Okay. Just because we're kind of not going, I mean, all of these are equal intervals here, but that very first jump, we're not doing an equal interval there with the rest, with everything else. Now, that being the case, if you should happen to, so for example, well, if you do establish an equal interval, then that's okay, yes. But with this, since we're kind of like jumping here, we're going from 0 to pi over 3, but then everything else after that's pi over 2, pi over 2, pi over 2, pi over 2 in length. So that one, no. But if it's like an equal interval the entire time, then you can leave it that way. So does that answer your question, I guess, kind of thing? Yeah, okay. All right, so let me give you guys one to try here. All right, so you guys try y equals the sine of x plus pi over 2. Okay, and just do one full period. Okay, one full period. Okay, so you don't do the entire thing, just one full period there is fine.
Okay. Is this just root 3?
I think it would end up simplifying to just root 3, yeah.
That's what I thought.
Yeah. Okay. Something like this. Now, granted, I didn't say that you had to do the negative pi over 2 to 3 pi over 2, so maybe yours started elsewhere, okay? But let me just go through a few pieces of information here first. So first of all, right, amplitude's 1, right? That's just taken from the number in front of the sign there. Period is still 2 pi in length. How do we know? Well, again, if you take your x plus pi over 2, and if you put it between the 0 and the 2 pi, and subtract pi over 2 from both sides, you get negative pi over 2 to 3 pi over 2. Okay, that length is still 2 pi, you just shifted it. Okay? So then we start at negative pi over 2 and go out to 3 pi over 2. Okay? So negative pi over 2 to 3 pi over 2, halfway between those two, well, if you add them together, is 2 pi over 2, which is really pi, divide that by 2, pi over 2. Okay? And the quarter points, well, halfway between negative pi over 2 and pi over 2 is 0, halfway between pi over 2 and 3 pi over 2, pi. Okay? So then there are your points. Okay, so yes?
If you say 1 full period and I do a little more, is that okay?
Yeah, that's okay. That's okay. As long as those extra pieces are correct, too. Yeah. Cooper's up here and asked too.
No, why isn't 0 start at 0?
So if you plug 0 in,
Yeah.
0 plus pi over 2.
Okay, negative pi over 2. Okay.
So by the way, what is this a graph of? A wave. Cosine. This is cosine. Sine shifted left pi over 2 is cosine. It's graph cosine. Okay? It's cosine. Questions on any of this? We're all okay? Sometimes we just give up.
Yeah.
No questions? No questions? Just give up? Did you get this?
I have pi over 3, don't ask why, but like, I got it now.
Okay. That's probably your first step, yeah.
I got it.
Were you having trouble with, like, so did you have this set up?
Yeah.
Okay. So minus pi over 2, right? So 0 minus pi over 2 is negative pi over 2. Subtracting pi over 2 from 2 pi, you want to make that 4 pi over 2, right? Make that 4 pi over 2, and then subtract pi over 2 is 3 pi over 2.
Sounds legit.
Okay, moving on. All right. All right, well, let's keep moving here. Let's add on some more complexity to it because this is too easy, right? All right, vertical shift. Bless you. Vertical shift is easier than the horizontal shift, I think. All right, and now we have all of our transformations. So y equals a, right? That's your vertical shift. Sine of bx minus c. That's your horizontal shift slash horizontal stretch. At the very end, plus d. Okay, and that plus d, that indicates whether we're going to go up or down, shift up or down, okay, from our original function. And of course, then the corresponding setup for cosine would just be replacing, sine with cosine. Okay, so same idea. Okay, so what this results then is a change to our range of our function. Okay? For just sine, or for just cosine, what's the range for just sine or just cosine? What's the range for those two? -1 to 1, right? Okay? Throw the A in front. Okay, throw the A in front. That's going to now do a vertical stretch. What's the new range going to be? No longer -1 to 1, but what? -A to A, right? If A stretches it to, it's like if A is like 3, right, then you're going to go from -3 to +3. If A is like 1/2, then you're going to go from -1/2 to +1/2, right? But now we're also going to shift things up or down a quantity of D. So D, okay, that vertical shift is going to shift. You can think of it almost like it shifts the center of our wave up or down, okay? And so now we're going to go A units above D, and we'll go A units below D. Okay, the amplitude above D, the amplitude below D, like that. And so then the range now is going to become D minus A, comma, D plus A. That's going to be our new range. Okay. D minus A, D plus A. All right, so let's see this in action here. And again, we'll do like a basic one. Sine of x plus 4. Okay. Now, this plus 4 is not inside the sine function. Okay. If the plus 4 were inside the sine function, what would you see? What additional symbols would you see here? Parentheses, right? You have to have parentheses around the quantity here, x plus 4, in order for it to be inside the sine function. So this is sine of x plus 4. Okay, on the outside there. So, what's the amplitude for this? 1. What's the period going to be? 2 pi, right? It's not a shift. It's not shifted and it's not stretched or shrunk at all. So amplitude's 1. Period is 2 pi. Okay. So all that's happening here is what? What's the only transformation we're going to have happen? Shift up 4. Okay, so since we're shifting up 4, I'm going to try and sketch my axes here in a more helpful way. Right? If we sketch them like we normally do, it might not be so easy. But I'm going to sketch it so that we're more in the positive direction here. So we're still starting at 0. We're still going to go out to 2 pi here. And I can go out to 4 pi if I want to and do 2 full periods. And then you'll find our halfway point, so pi. And then the quarter points, pi over 2, 3 pi over 2. And the halfway point here, 3 pi. And then 5 pi over 2 for the quarter points and 7 pi over 2. The center of our wave was on the x-axis, right? The wave was like kind of centered on the x-axis. Now with this vertical shift, it'll be centered on what? So it was centered on the x-axis here, or the line y equals 0, right? So what would the new center be? Yep. Not x equals 4, y equals 4, right? We're going to shift it up 4, so 1, 2, 3, 4. Okay. What about the negative 1? Say again?
So isn't it like 1? Never mind.
So this is the center of our wave. This is the center of our wave. So then according to our amplitude, what's the highest value we're going to obtain here? 5. Right, because this is the center of our wave, but our amplitude goes up 1 from that, so we're going to go up to 5, and down 1 from this, so 3. So it's going to be between 3 and 5 now. So 4 is our center, we're going to go down 1 and up 1 from that. If you like, which I think is maybe a good idea here, you can even like draw like a little dotted line to help guide the center of your wave there through that 4. Okay, I think it's helpful to do that, just for a guide. So now let's plug in an x value here, right? So we'll start with 0. 0, what's sine of 0? 0, but then plus 4, 4, right? So 0, 4. Okay. Plug in pi over 2. What's sine of pi over 2? 1 plus 4, 5. So pi over 2 is 5. Okay? Plug in pi. Sine of pi, 0 plus 4, 4. So it's pi 4. Plug in 3 pi over 2. Sine of 3 pi over 2 is negative 1 plus 4 will be 3. And I think you get the idea from there, right? 2 pi will be back at the axis. 5 pi over 2 will be above the axis. 3 pi back on the axis. 7 pi over 2 below the axis. And 4 pi back on the axis. And so you can kind of like connect your dots. Okay? So there it is, shifted up 4. Okay, any questions on that? Yes.
Are you gonna ask us what the range is?
So potentially you should be able to identify the range here, yeah. Yeah. So what would the range here be in this case? Anybody? 3 to 5, right? 3 to 5. 3 to 5. What's the domain here? Negative infinity to infinity, right? Yeah, that's you can plug in any number here you want. Any real number. All right. Questions on that? Yeah.
Well, it's kind of related to that. Do the other equations have limits of that? Like, do they?
Kind of.
Oh, because.
You gotta think reciprocals and stuff like that. So you're talking about so tangent and cotangent, they're kind of like unto themselves. And then secant and cosecant relate to these very closely, but they're gonna be reciprocals. And so we'll talk about that when we get there.
No, like the other equations that we were working on right before, like did we have to stop or could we go on for like however long of a period?
I guess I'm not quite sure I understand your question. So I drew 2 full periods here, but you should normally I'll ask you only do like 1 full period or 2 full periods, and that's about it.
But it's still for the range, would it be that it would be the negative?
The range here for this graph,
No, the domain.
domain here, negative infinity to infinity. Yeah, you would include just all possible numbers that would work, kind of thing. I would say when you describe the domain of this, not just 0 to 4 pi. For example. Yeah. Okay, I see what you're saying. Yeah, Ramika. Say it one more time. Sorry. Do we get to 5? Yes. So include absolutely. Yeah. Yeah. So cosine and sine, their range is -1 inclusive to 1 inclusive. And so then when you stretch and shift the upper and lower, you reach those points. You reach them. Okay. So do we need another example of vertical shift?
No.
Okay. All right. Well then now we're gonna do some fun ones. These were too easy.
Study.
What's that?
Can we just study?
Can we just study? We are studying right now. We're working together.
Okay.
Mutual studying. All right, let's put it all together. Y equals. That's not the spirit, Megan.
I'm sorry.
Like the little engine that can't.
I quit.
I think I can't. I think I can't.
I quit.
Don't give up.
I learned this today.
Dude, I'm just like maxed out.
Don't give up. You can do it. All right, number 1. I'm going to give you some steps that I like to follow. You don't have to follow these if you don't want to, but I find that it's helpful. Okay. So first thing I like to do is to identify the vertical shift. Okay, and I think of this as like the new center, okay, or the new x-axis you can think of almost. Okay. All right, so we can do this, right? We got this. What is the vertical shift of this function? 2, right, the +2 at the end, right? That is not inside the sine function. If it was inside the sine function, you'd have parentheses around it, so it's +2 at the end there. So we have a vertical shift up 2. Okay, it's good to know. So what I might do then is go ahead and just I want to leave myself some space. Let's do that here. Okay, so we'll say there's 1, there's 2. So there's my shift up 2. I'm going to go ahead and draw that little dotted line. That's kind of like my new axis there. Okay. Number 2. Okay. We'll find the period. Okay, which remember that's just the 0 less than or equal to bx minus c less than or equal to 2 pi. Now, by the way, right, since we've shifted up 2, what's the highest that we're going to go from that 2? 3. So we're going to go 3 up from our new center of 2, right, where we shifted up 2, but then that amplitude there says go up 3 further, right? We're going to go 3 up from that. So actually we're going to go up to 3, 4, 5. And then we're also going to go down 3 from that new center. So 1, 0, and then negative 1. So that's going to be our lowest low there is negative 1. Okay. So 3 up from the vertical shift, 3 down from the vertical shift because of the amplitude of 3. Okay? So find the period. All right, let's do that here real quick. So what's the bx minus c here? What's going to affect our horizontal stretch and our horizontal shift here? What's the only thing that's going to affect that? The what? What part? The 2x, right. So we'll put the 0 less than or equal to 2x less than or equal to 2 pi. That's our normal period. But now we have to solve for x here. So what should we do to the different sides here? Divide by 2. And so we get 0 less than or equal to x less than or equal to pi. Okay. So our new full period is from 0 to pi. Okay, and so let's go then 0. I'm going to do 2 full periods here, so we'll go from 0 to pi. I don't know, let's say like there's pi. Okay, and then so if the 1 full period's pi, then if I want to do 2 full periods, I have to go out to what? 2 pi. Okay, and then we'll find the halfway points and the quarter points too. So halfway between 0 and pi over 2. Halfway between 0 and pi over 2, pi over 4. Halfway between pi over 2 and pi, 3 pi over 4. Halfway between pi and 2 pi, 3 pi over 2. And this will be then 5 pi over 4 and 7 pi over 4. Okay, and so then we use that to, we plotted the start, middle, and end points of the period. And number 4, plug in / use the pattern to plot points. Okay. With what point should we start here to plug in with? We're going to plug in what first? We could start at pi if we wanted to. Pi is the start of one of the periods. But if you look here at our very first period we chose, 0 is the starting point. So let's plug in 0 first. Okay? 2 times 0. 0. Sine of 0. 0 times 3 plus 2. 2. So at 0, we're at 2. Plug in pi over 4. 2 times pi over 4. 2 pi over 4 or pi over 2. What's sine of pi over 2? Sine of pi over 2 is 1 times 3. 3 plus 2. So at pi over 4, we're at 5. Okay? At pi over 2, what y value are we going to be at? At the 2, right? So we were on the axis. We went up 3. We're going to go back down 3 here to pi over 2. At 3 pi over 4, what's our value going to be? Negative 1, right? Our lowest point. And then we're going to, at pi, we'll go back to 2. And then 5 pi over 4, 5. And then you get the idea, right? 3 pi over 2 back to 2. 7 pi over 4 to negative 1. 2 pi back to the 2. And then we can just connect the dots.
So once you get like the first pattern, can you just keep it going?
Yeah. Yeah, once you kind of get the hang of it, then you're good to go. Okay, really, sine always starts on the axis. So if you remember where we're working with sine here, you'll always start at 2. And then if it's positive sine, you're going to go up and then axis and then down and then axis. Cosine starts above the axis, goes to the axis, down, axis, up, axis, down, and so on and so forth. So you even don't even really need to plug in your first point as long as you are familiar with the parent function of sine, the parent function of cosine. Okay? Let's do one more. Yes, I know. One more here. Okay? One more. Any questions on this one, though? Okay, this one we'll just do one full period. Okay, we'll just do one full period for this next one here. So, another one. Y equals 1 minus 2 cosine x minus pi over 4. Okay. Now, I'm not the biggest fan of the way this is ordered, right? I like to normally see the cosine function first and then the one. So if I wanted to flip this around, how could we rewrite this? If I wanted the cosine first, it would be negative 2 cosine, right? X minus pi over 4, and then what would be out here? Yeah, plus 1 like that. Okay, isn't that the same thing, right? So I rewrote it like that just to be helpful here. Okay. Do we have a vertical shift? Yes, we do. Vertical shift, how much? Up or down 1? Up 1, plus 1, right? So up 1. So our new center here will be at 1. And again, I'll just draw like a dotted line. Like that. What's our amplitude? 2. So that means from that center of our wave at 1, from the center of our wave at 1, we're going to go up 2 from that and down 2 from that. So up 2 from 1 is 3. Down 2 from 1 is negative 1. Okay, and then we also have to take care of our, looks like we have some sort of adjustment to our period as well. So 0 less than or equal to x minus pi over 4, less than or equal to 2 pi. So we have to add pi over 4. So 2 pi is 8 pi over 4, so adding a pi over 4 would be 9 pi over 4. All right. So again, I'll just do one full period here. So I'll say, I don't know, here's pi over 4. I'll say 9 pi over 4 goes out to, I don't know, here we'll say. And then I want to find the midpoint of that. Find the midpoint, I'm going to add them together. Pi over 4 plus 9 pi over 4 is 10 pi over 4. Or in other words, 5 pi over 2. Divide that by 2, 5 pi over 4. Okay. And then halfway point here, pi over 4 plus 5 pi over 4 is 6 pi over 4, which is 3 pi over 2, divided by 2, 3 pi over 4. Okay, and this will be then 7 pi over 4 right here. Okay. I'll let you guys catch up here first before I proceed. Any questions up to this point? Anything about what we did here? Okay, we're all good. All right, so now let's just plug in our first point here, just kind of get our bearings about us. Let's plug in that first point, which is pi over 4, right? So pi over 4, take away pi over 4 is 0. Cosine of 0 is 1 times negative 2 plus 1. So at pi over 4, we're at negative 1. Okay? This is a little bit funky because normally when we graph cosine, we start above the axis, above the center here. Why in this case do we end up starting below the axis? because that negative in front of the cosine right there, -2, right? The amplitude, we still describe it being 2, but that -2 reflects it over the axis there, and so it, instead of starting up, it starts 2 below, okay? Plug in 3 pi over 4. 3 pi over 4 minus pi over 4 is pi over 2. Cosine pi over 2 is 0. Times -2 is still 0. Plus 1 is 1. So at 3 pi over 4, we're at 1. Okay? So we go from below the axis to on the axis. And then at 5 pi over 4, we're going to be at what? We're going to go 2 above it. So to the 3. Okay? And then at 7 pi over 4 will be, what's the pattern going to be here? We went up, up. And so now back down to the axis, and then 9 pi over 4, we're going to end up where? -1, okay? So it goes up like that, and then down like that. Okay, and it keeps going, of course, you know. So on and so forth. Okay. So there it is. All right. Questions on any of that? Okay. Just in awe of the beauty of it. I know. Right.
I know this one's right, but I just never know what this is.
You have the 1 and the √3 reversed.
Thing I just
Think biggest, opposite, biggest.
I know it.
Smallest, opposite, smallest. Okay? So that's it. We made it. Woo! All right, so your homework, page 326. Numbers 29, 33, 49, 57, and 73, and 94.
So, is the tangent of -3 2 pi over 3?
Say again? Oh, the tangent of theta, when is that equal to -√3? Okay, I got you. Yes, you may. It'll be 2 pi over 3 and also
What's the other one?
5 pi over 3.
But we'll do the first one.
Okay.
We learned about rho, theta.
Yeah? And phi, whatever you say. Phi, pho, phum. He says phi.
But it always just looks like it should be just like, yeah.
I think phi is what I've heard. So.